Hey, this is Step Amit. Welcome to my Exorcism.io series. In this video, I'll be working through the scale generator exercise from the Exorcism.io Ruby track. So in this exercise, we will be given a starting note, which it's called the tonic, in a set of intervals. And what we need to do is generate the musical scale starting with the tonic and following the interval pattern. And so there's a little bit of music theory here that you need to understand to really do this. Scales, I'll just read it to you here. Scales in Western music are based on the chromatic scale, a 12-note scale, and it can be expressed, it says here, as the following group of pitches. Starting like A sharp, B, C, C sharp, D, D sharp, E, F sharp, G, and G sharp. And if you've ever seen a piano keyboard, you know that there are white notes and black notes, white keys and black keys. And this B to C, see how there's nothing in between. These are two white keys that are right next to each other. There is no black key in between them. These two notes are a half step apart, and it's the same for E and F here. But those black keys, which here are the sharps, can also be represented by flats. So A sharp can also be called B flat. And they're exactly the same pitch, but conceptually they're different. They perform different functions. And so sometimes we express them as sharps, sometimes we express them as flats. And so the major and minor scale and modes are subsets of this combination of pitches. They're just they're groups of notes out of these pitches. But in some cases, again, we use the flats. In some cases, we use the sharps. We don't combine them in a given scale. And so here is the list of which scales contain which. So C major and A minor contain no sharps or flats. It's just these pitches right here. But the C and A chromatic, of course, do, and at least for the purposes of this exercise, they are going to be represented with sharps. And so I think I'm going to be grouping C and A minor together with the sharps. But here are the keys that will use sharps. G, D, A, E, B, and F sharp major will use sharps, as well as E, B, F sharp, C sharp, G sharp, and D sharp minor. And you'll notice that the minor keys are represented with lowercase letters, the major keys with uppercase letters, and that's something that's going to help us. And then these are the flats: F, B flat, E flat, A flat, D flat, and G flat major, as well as D, G, C, F, B flat, and E flat minor. Okay, and then the other thing we need to know here is that in most cases, the test will be handing us a set of intervals represented by letters, uppercase or lowercase letters. And they represent the steps in between these things. So the smallest interval is a half step. As far as if you think about a piano keyboard, there are other music systems that have other types of intervals, but these we're just concerned with three here. A half step represented by a lowercase m, a whole step, which is two half steps represented by an uppercase M, and then an augmented first interval, which is three half steps, and that is going to be represented by an uppercase A. Okay. I mean, that seemed pretty confusing to me. I know what's going on because I was a music theory major, at least for a while, but hopefully you'll be able to follow along here. So let's go ahead and grab this and pull it down. Copy in my rake file, which allows me to run my test just by typing rake, and I've got that wired up to a keyboard shortcut inside of Vim. start a tmux session for this. And I'm going to go ahead and remove the Ruby file. All right, let's see what this test looks like. So we have a file called scale generator, which will contain a class scale with an initialize method that takes a tonic, a mode. So the type of scale is called a mode, and it will return a name. There will be an instance method name, an instance method pitches that will return an array of notes, and it looks like our initialize method needs to take an optional set of intervals. So chromatic, you don't need to pass that because that's just 12 half steps. So if nothing's passed, it's going to be every half step. All right, that's enough to get us started. So actually, let me open up my test running pane. Run the test, which will fail because that file no longer exists, and then I will recreate it. Swap my panes so that my class under test is on the left and my tests are on the right. And just keep going. And I'm usually, if you've watched these videos, I'm super strict about my TDD most of the time. And so I'm just going to let the tests guide me and do as little as possible between steps. So now what I need to do is initialize my class. And the other thing I like to do is when I run the test, I like to predict what's going to happen before I run the test so that I'm thinking, so that I'm on top of what's going on here. And sometimes I'm surprised, often I'm right. So what's going to happen here is it's going to fail again, but it's going to fail for a different reason now. It's going to fail because I don't have an initialize method. It's going to fail because it's expecting an initialize method to take 2 arguments. Yep, given 2, expected 0. So we need to define that. So I'm going to go ahead and create an adder readers here for tonic and mode. And then create the initialize method to take tonic and mode. And then set those instance variables. And then now it'll complain that there's no name method. Undefined method name, okay? And name, I believe, is going to be simply tonic plus the mode. So let's create an interpolated string here to return tonic and mode. Okay, tonic was lowercase there, so let us capitalize it. And I'm intentionally using capitalize instead of uppercase because I know that we were going to represent flats with a lowercase b here. And I don't want it to be an uppercase b. So capitalize will just capitalize the first letter there. Okay, so that worked. Next test, it's going to fail because we don't have an instance method pitches. So I'll need to create that. All right. And pitches needs to return an array of pitches. And so what I'll do to begin is I will literally just grab this and return it, because this is going to represent the chromatic scale as sharps. And so that worked there for that test, to just return that hard-coded result. But a different chromatic scale will not work for 2 reasons. One, because it starts on a different note. And Also, it uses the version with flats instead of sharps. So let's go ahead and see this fail. Okay. So what I need to do here is I'm going to pretend that I have a chromatic scale hash that I can select either flats or sharps based on some condition. In fact, I'll just call it flats or sharps. Flats or sharps based on some condition. And for the moment, I'm going to create flats or sharps real quick. And I'm just going to hard code this. Return sharps if tonic is C. Otherwise, flats. And I'm not going to leave that very long. I just want to be able to see this pass here. So chromatic scale needs to, this will be a hash. And so I had sharps. And I need flats as well. So this is D flat. Let me line these guys up. There we go. D sharp is E flat. F sharp is G flat. G sharp is A flat. And A sharp is B flat. By the way, yeah, I mentioned that I was a music major and I used to own a recording studio. I've played guitar since I started learning when I was 5 years old. I also played French horn growing up. Just in other words, I'm a lifelong musician turned software developer. And I know a lot of people for whom that is true. In fact, most of the people that I played music with back like in my college days are some sort of developer, some sort of software developer. If that's you too, if you found that to be true, please comment on this video and let me know. Let me know. Okay. All right. So this should work for the C. We should have one failure still. Oh no, we have two failures now. Because flats or sharps, wait a second. If the tonic is C, here, okay, one failure, F failed. And the reason why F failed is because even though we're selecting flats, we're starting with the wrong note. So we have to do one more thing here, and then we'll actually come up with a more legit way of determining flats or sharps based on the list they gave us. What we really need to do is we need to rotate this scale, rotate this array. And so when you rotate an array, you give it a certain number of steps, and it will, whatever number you give it, that's going to become the new first element in the array, and whatever was before it will be shifted to the end of the array. So that's what we want to do here. We want it to rotate around. And so let's see. We want that chromatic scale. You know what? That's okay. I'm just going to do it. I'm just going to dumb it out here and be as explicit as I can at the beginning, and then I'll refactor in a minute. Chromatic. So I'm going to repeat this exact same thing here. Flats or sharps. I need to find the index of tonic.capitalize. I need to rotate it around there. Is this right? Did I do this right? the index of the tonic. So what I'm doing, I'm simply selecting. So for here, for F, I know it's going to be flats. I'm going to find tonic here. And I want to rotate by the index. And what that'll do is it'll put this at the beginning. And so then we'll go from F to E. Yes, that was it. Pretty ugly at the moment. Not going to worry about it yet. I will refactor it in a bit. Okay, test naming major scale. That should work. No, okay. Yeah, this fails because, we're passing a set of intervals here. So let's just accept them. Let's add a third, add a reader here for intervals. And then grab them there. So just like this, it's going to make the other test fail because we're not passing. See, given 2, expected 3. So we need to default this. And what I want to default it to is the chromatic intervals, which of course isn't defined. I'll define it now. And that's 12 half steps. So okay. And so for name, that's fine. But now we're actually going to have to use it. And so this is going to be a little bit tricky. Because as you see, we're returning all 12 notes, but we want to just select. We want to select notes based on the intervals. So if you look, the intervals we have are big M, little m, big M, big M, big M, little m. And so we want, starting at 0 here, we want a big M, which is 2 steps, big M, little m, right? And then big M, big M, big M. See how that works? So let's plan this out a little bit. We've been given M, 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 M. And we know those can be translated into numbers based on half steps. So if a little m is a 1 is a half step, this is 2, 2, 1, 2, 2, 2, 1. And if we have our scale there, starting with C, what we want to do is select values at a list of indexes. Well, array in Ruby has, where is it here? Has a method values at that you can give a list of indexes to, and you'll get those particular elements out of the array. So if we had that, if we could translate somehow these intervals into indexes starting at 0 and hand that to our rotated chromatic scale, then we can get the scale that we want. All right, so we want to somehow translate this into starting with 0. Notice we only want this, the same number of notes as we've got in our original array, 7 notes. So that tells me that this is some kind of map operation that we're going to be doing, because we're going to get a new array that's the same length as an existing array, using the existing array to come up with the new value somehow. So if I start at 0 and I come here and I add the last, this value here to 0, that gives me 2. If I add 2 again, I get 4. Then I can add 1, that gives me 5. So you see, I'm just looking back one. What was the last one here? So this value is now 7, then 9, then 11, and I just throw away 1. I throw away 1 because 12 would get us back around. That's an octave. That would get us back to C. We don't want that. I need to be able to, I need this somehow. I need to be able to do this. Okay. And so what does that look like? Pitches. I'll just add it here. I'm just going to keep going. Values at, and so I need those indexes somehow. Let's call it note indexes. I need these. And so I need to translate those intervals. I need to translate those intervals. Okay. First off, okay, let's see. So if I've got, but I can't just do a pure map, right? Because I have to keep track of what that next index is. So let me go ahead and initialize this. Next index, I'll start it at 0. And then I'm going to map over these intervals. And I'll just call this interval because it's that interval. And let's see. So the index, I want something to return for this one. And that's I'm going to call that index. That's going to be equal to the next index. And the reason I'm setting this and using another variable here is before I return that, I need to increment, or I need to add to this. I need next index to be, let's see, I need to add interval to it. And I'll tell you, let me explain why. The first time through, let's say my interval is 2 because it's capital M. Well, I want this value to be 0 on that first one, but I want to remember this, right? So I want to set the next index. What is it going to be the next time through? So next index, I want to add interval 2. And so now that's going to be 2, but I want this to be 0. And so same next time around. So see, on the very first one, I'm setting next index to 0. My interval is 2. I want to set next index to 2, but I want this very, very first element to be replaced with 0. And so now next index is 2. So the second time around, I come in up here. Next index is 2. So I set index to 2 because that's what I want to return. But then I want to add 2 to next index so that it'll be 4 for the next element in the array. See, and so on and so forth. So that's what's going to happen here. But the problem is, I think my intervals are, did you mean tap? This might not be helpful. Yeah, undefined method map for string. Yes, okay. So my intervals are still letters. So I need to do a couple things. One is I need to get the chars, but then I need to map it. And I'm going to make a hash mapping the letters to numbers, and I'm going to call that intervals. So let's do that up here. All right, and so lowercase m maps to 1, uppercase m maps to 2, and then uppercase A maps to 3. And values at, oh yeah, one more thing I got to do. I have to use the splat operator here. This is an array, but values at doesn't take an array. It takes individual integers. So I need to expand. The splat operator will take my array and expand it into individual arguments for values at. Okay, that works. I think that might be it. No? Okay. Oh, you know what? I've never made flats or sharps do the proper thing. So they gave us a list here of flats and sharps, and so what I want to do is I want to turn these into turn these into like arrays in a hash and look up which set sharps or flats. So let me go ahead and do that here. And so sharps, this is really going to be a lookup. So let me set these up first, and then so for the keys, flats. Flats is going to be, let's see, F, B, B flat, E flat, A flat, D flat, and G flat major. And then D, and see how these are lowercase now? G, C, F, B flat, and E flat minor. These are the flats. And then sharps. And I'm going to add to theirs. I'm going to add C. And remember, I'm going to add C and C major and A minor, because the chromatic versions of those scales will use sharps. Even though C major and A minor scales do not have sharps in them. Okay, let's see. C, G, D, A, E, B, F sharp, major, E, B, F sharp, C sharp, G sharp, and D sharp, and A minor. All right, and so then for flats or sharps, what I need to do is take that keys, and I'm going to find. And so when you find on a hash, and find comes from enumerable. When you find on a hash, you get key and value. I don't care about the key. I only want to check the value. So this is a convention that we use to show that we don't care about this. We're not going to use it, but we have to. We're given something, so you just use an underscore to indicate that. This is a visual thing. It doesn't do anything magical. It's just a visual indication. And what I want to know is, does that array include my tonic? And when you use find on a hash, what you get back is you get back an array. You don't get back your hash. You get back an array, and in this case, it would be it would contain sharps, the key sharps, and then it would contain the array of C, G, D. And so what we want is the first element of the array that we're given back. So first will give us our key. And that works. All right, test minor scale. I think that will work. So I think this is all the functionality we need. And so I think these are gonna pass now. And I'm just gonna want to refactor a little bit just to clean up a little bit here. Okay, let's see. Test Lydian mode, that should just work. Phrygian mode, yeah, I think we're done with the implementation. Locrian, harmonic minor. Octatonic. Hexatonic. Pentatonic. Enigmatic. Enigma. Interesting. All right. So based on their rules, I don't know that this is that this is exactly how this works. Man, but according to their rules, this implementation works. This is how we can determine whether to use flats or sharps. Okay, let me see what we can clean up. Let me get rid of my notes there. I think this is about as clear as we could make it. We could make this more concise. We could do this all on one line. We could next index plus equals interval and then subtract interval. We could make that the only line here. That'll work. And what this will do is it will add interval to next index. So next index will be queued up for the next time through this when we hit the next element, the next iteration of this map. But it will subtract interval again to set the value, right? That's what we'll return to set the value for this element in the new array. But this is one of those cases where this is too clever, right? This is something you can do in Ruby, but it's a little bit too clever because when I come and look at this in 6 months, when I need to change this code, I'm not going to know this is going to take some untangling. It's not immediately obvious what's happening here. So this is a case where you can be too clever. So I would back it out and do this. I feel like the naming is super clear. Like next index, that's the index we want to use next time. And it's made even more explicit by setting index to next index before we add interval to next index and then returning index. Anyway, so I'm going to, short story long, I'm going to leave note indexes alone. Pitches, I think we can do a lot here. Okay. Let's see. This whole top line is our rotated chromatic scale. Let's to begin with, I'm just giving that big chunk of code a name. And then on 31, let me get rid of this space. And then we can do a little bit more here because there's too much going on. There's this duplication of grabbing the flat or sharp scale. And I think I can let me just call that chromatic scale. Which selects flats or sharps from the chromatic scale. All right, so I can replace this with that as well. And then also I'm doing two things here in this method right now in rotate chromatic scale. I'm doing the rotate, but I'm also determining how much to rotate. And so I think I'm going to pull this out into its own method called scale rotation count. And so this method, let's see. This method here is now just doing chromatic scale index tonic dot capitalize. And that's giving us that's the rotation count. It's the index of the tonic in the chromatic scale. And then the rotated chromatic scale is a chromatic scale rotated by that amount. And then backing back up, we use that up here. Pitches is the rotated chromatic scale values at note indexes. All right, note indexes. We translate our intervals into a set of indexes that we pull from there. Okay. Oh yeah, chromatic scale here is flats, or we grab flats or sharps from the chromatic scale, and we determine whether to grab flats or sharps based on our keys hash. We look to find tonic in our keys hash. Okay. I think that's it. Let me submit that. All right, cool. Well, thanks for watching to the end. If you got value out of this video, please hit the like button below so that it's easier for people to find. And go ahead and subscribe if you want to keep up to date with these and stay up with this series. And if you would like a deeper dive into how I approach refactoring and really just get a workflow for how to approach refactoring in lots of different situations so that you can write code today that you won't hate in 6 months and become a hero to your team, check out my tactical refactoring video course, which I have linked in the description below. All right, I'll see you in the next video.